So solutions are made of solutes that's redissolved into a solvents so that we get the solution, which is the mix of solute plus solvents. So in this video we talk about first what means dissolve for the solvents, for the solutes or into the solvents, and we talk about the relationship we have between the chemical amounts of the solid on one side and the thing which that we get into solution. So we talk about it, and we talk about two kind of bonds that will help us to understand what we said before. Okay, so the first step is about the two kind of solute we can have. So the first kind of solute is ions, like Na plus Cl minus. So what happens if we have as a solute we have salt and ACl, solid, so we have S just there. We get two ions into the solution, meaning that when we put this solid into the solution, we have molecule of water coming and attracting these ions. So these ions are separated, and we do not have this molecule anymore. We just have this and this into the solution. So this is the same case with FeCl3. The only difference with NaCl is that we have 3 Cl minus for one FeCl3. Now, with the case of molecular compounds, this kind of compounds, the solute is a molecule and the solute there is a molecule, but what we have within the solution is a molecule too, meaning that water has not been stronger enough to cut this molecule into small pieces like we did with ions. Just there, we had one piece at the beginning, we have one piece within the solution. So why do we have this difference? Let's talk about the bonds between the different parts of these solutes. The first one, when we get ions, Na plus and Cl minus are linked into NaClS by a bond which is named ionic bond, because it exists because of the attraction of the positive charge and the negative charge. So they both attract themselves, and we have a link between them. So we can touch salt. I think you already touched salt in your life. If you didn't do that, we'll do it to the next lab if you need that to have a better life. And as you can see, they are linked together. We do not have ions in our hands. We just have this. And when we put it in water, this link is broken by the attraction of water that creates new links with Cl minus in one case and Na plus in the other case. That's why we have aqueous there, because aqueous is for water. So we have the same with Fe3 plus and Cl minus. So now into the molecule we have covalent bonds, meaning that we have each atom bringing electron, and we have the sharing of these electrons. So both electrons are shared by both atoms. That's why you have this kind of link. And as you can guess, I think covalent bonds are stronger than ionic bonds. That's why with water, if water attracts the different part of the molecule, we cannot split the molecule into pieces. We cannot do that because covalent bonds are stronger than ionic bonds. So the last point for this video is the link between the chemical amount of the solute we have and the chemical amount of the ions we get inside the solution. So why do we need that? Because we need to calculate the concentration of Cl minus, which is written this way. This is the way you have to use. For Na plus, we can do the same. We can write it this way. And just try not to forget aqueous. So to calculate it, as you already know, this is the quotient of the chemical amount by the volume. So we know the volume, we have to calculate N, which is the chemical amount. So we need this N for this concentration. So we have to link this chemical amount to this one. As we can see into the chemical equation, when you have 1 NaCl, we get 1 Cl minus. So if we add 1 mole of NaCl, we get 1 mole of Cl minus. So in this case, this is really easy. We know the initial mass of NaCl, so we get the chemical amount of NaCl, and we know that it's equal to the chemical amount of Cl minus. This is what we're looking for. Now, if you have this situation, as you can see, for one molecule of this, we get one molecule of this. So this is the same one, N equals N. In the last case, which is different, why is it different? Because you have 3 just as a coefficient, meaning that if we add one molecule of FeCl3, we get 3 Cl minus. If you get 2 molecules of FeCl3, we get 6 Cl minus. So what is the link now between the chemical amounts? So there is one relationship you can keep and you can use every time, meaning that N of FeCl3 divided by its coefficient, which is 1, equals to N of Fe3 plus divided by its coefficient, which is 1, equals N of Cl minus divided by its coefficient, which is 3. So whatever happens, if you had something else with 8 as a coefficient, it will be that stuff divided by 8. So now, if we want to get N of Cl minus, using this equation, we can say that N of Cl minus equals 3 times N of FeCl3. This way, having the mass of this that we use to make the solution, you can calculate the chemical amount of this, and if you multiply by 3, you get N of Cl minus. And then you can calculate your concentration. And the party is now over.